medium level problem of LeetCode, which is insert interval. In this problem we have given the some intervals, you can see here, and we here in each intervals we have given some in starting point and ending point, which is represent the starting value and ending value of ith interval, which is sorted, also given the which we are here storing the ascending order by starting value. And then we have given the new interval which have to insert in the intervals, and then we have to return the intervals. You can see here we have given the intervals, and which is 1, 3, 6, 9, and new intervals which is 2, 5, and we have to return the new intervals after merging inserting 2, 5. So here you can see 2, 5 can be merged with 1, 3. That's why we are here we are merging 2, 5 with 1, 3. Then new interval is minimum of new intervals is 1, 5, which is starting value 1, which is minimum for 1, 2, and ending point is maximum of 5, 3, which is 5. And then we have to return, and then we again checking the 1, 5 can merge with 6, 9. Here you can see 6, 9 cannot be merged, so we insert 6, 9 here, and then we return the new intervals. In the second test case, the intervals are given 1, 2, 3, 5, 6, 7, and 8, 10, and 12, 16, and new interval which is 4, 5. Then we are checking the 1, 2 can be merged with 4, 5. If we cannot, then we insert the 1, 2, and then we again checking 3, 5 is merging with 4, 8. Here you can see 3, 5 can be merged with 4, 8. So here new interval become 3, 8, which 3 minimum of 3, 4, which is 3, and maximum of 5, 8 is 8. So here new interval is 3, 8, and then we inserting 3, 8 here, and then we again checking with this 6, 7. Then 3, 8 can be merged with 6 and 7. Again new interval is 3, 8, and then we are again checking the 3, 8 can be merged with 8, 10. Then you can see 3, 8 can be merged with 8, 10. Then we new interval is 3, 10, and then we again checking 3, 8 can be merged with 12, 16. Here we can't be merged, so we insert 12, 6. Then we have new interval is 1, 2, 3, 10, 12, 16, which is we have returning here. In this test case, you can see here we are we check through the each and every step. We are seeing each and every step. First we declare a new empty intervals, and then we insert in the new intervals which is 4, 8, and we are checking 4, 8 can be merged with 1, 12. Here we can see 1, 2 cannot be merged with 4, 8. So here 1, 2 insert first, so basically we insert first 1, 2, and then we insert 4, 8. And now 4, 8 we are checking the last interval of the resultant interval. Here this one is the resultant interval, and we always checking the last interval can be merged with the ith intervals. So here this is the initially, and then we are checking with 3, 8 can be merged with 4, 8. you can see for 3 comma 5 can merge with 4 comma 8, so new interval is 3 comma 8. And then we checking 6 comma 7 can be merged with 3 comma 8, then again this interval can be merged 3 comma 8. So here new interval is 3 comma 8 again. And now we are checking this 8 comma 10 can be merged with 3 comma 8. Then you can see the ending point of that interval is equal to starting point of that interval, so we can merge of both of them. So our new interval is 3 comma 10. And now you can checking this 12 comma 16 can merge with 3 comma 10. You can see the ending point of that interval is should be less than starting point of that interval, where is 12. So you can do not be merged, so basically we direct insert of that interval. Then after the iterating through all the interval, then we get the new interval which in the resultant, and then we have to return. Here we are saying that all the condition of interval where they can merge or they cannot be merged. Here in this one is both of them. In this here, in both of the condition we cannot be merge, and here we are saying that in the we can merge with interval to interval. So we are writing here C++ code. In this here we are declaring initially empty interval, and then we insert the new interval, and then again then we check the last. Always we are checking the last interval, so we are storing the last interval in the form of u and b, which is starting node is u and ending node is b. And then we erasing the last interval from the resultant intervals, and then we are storing the ith interval of that intervals, so which is storing s and a. And then we checking here we are checking this condition is that one where the both interval cannot be merged, and that's why we are writing if u is greater than a, then basically our resultant the new vector new interval new interval where the ending point is should be lesser than the starting value of the last node. Then we basically we insert the first that interval, and then we again insert that last one last interval which is it. And then if this condition where b is lesser than s, that means here this condition yes is greater than b, then we basically we have yes is greater than b, then we storing inserting first u and b interval, and then we are inserting the yes and e interval. That's why here we are inserting u and b interval where it is basically storing in it which is basically u and b, and vector basically yes and a. So that's why we are storing first last interval, and then we are storing ith interval. And then here we are written the condition where we can merge two interval. That's why we are storing the new starting node which is minimum of s comma u, and new ending node which is maximum of p comma a, and then we basically insert in the resultant interval, and then we iterate through all the interval, and in the last we have to return the intervals which is vector. So here you can see if we are submitting, then here we are submitting, then that code is accepted, and here you can see here we are submitting, then this code is accepted.